Captain Space Weather! Taking a look at the sun on 171 angstroms in the mid-afternoon hours. A rare mid-afternoon smasher video. Got an active region rising, and we got a crossing of the magnetosphere. I should say a crossing of the magnetospheric editor's note, not magnetospheric, heliospheric current sheet. Some of the hardest words in astronomy to say. Cheers. And let's look at the total electron content over North America, something we don't necessarily always do. We got a new segment coming up, a new data set that we're going to look at every single day. Here it comes. 1224, 1225, 1226. However, before we get too into that, let's look at the most recent situation regarding earthquakes, as we have had some since our previous update. Let's go back 6 hours. Philippines gets a 4.5. Japan gets a 4.1. Tonga gets a 5.6. And also a 6.0, but at depth. Tonga remains on alert for a 6+ earthquake. Also a 4.8 in Japan. Otherwise, basically a lull in activity. As the magnetic flux increases, we should expect an increase in earthquake activity. Why do we say that? Is it because of the X-ray flux? Is it because of the electron flux? The cosmic ray flux? Nope, it's because of the magnetometer. Let's look at that first. Currently at a relatively high level, then experiencing a little abnormality there. We see a disparity between the two different satellites, so that's something to keep an eye on. Let's look at the rest of the data while we're on spaceweathernews.com. You see a dip in the X-ray flux. Phi angle. One little blip near the middle. The rest is Earth to Sun magnetic hydrodynamic flow. Solar wind density well below 10, more like 3. Solar wind speed still low. KP index 1. Here's your signets. We'll let that play through. That's 1223 through January 2nd, I believe. That's your guess on the heliospheric current sheet. Electron flux is lower than it's been. And the ionosphere is quite discharged. Check it out. The charged part is pretty normal. The discharged part is a little anomalous. Nothing too extreme. There's your auroral forecast, super weak. Let's switch gears for a minute to the US NASA GOES water vapor map. You can see a convergence zone down here, where your dry mass of air is meeting up with a moist air mass. Jet stream is in this area. And so your main storms in the US are going to be in this area right here. Finally, let's take a look at the Arctic sea ice thickness and volume. First, let's look at this graph. There you go, the black line is where you currently are. And please note the extremely cold spring and the early winter, as most of the northern hemisphere have experienced. Next, let's look at the actual map. And as far as the sea ice being gone, and this is as of Christmas Eve, by the way, you will note the Arctic Circle is 100% ice covered. Remember, when there's ice on both poles, that's an ice age. Lastly, let's look at the new segment. Here is the heliospheric current sheet in terms of magnetism. This run goes from 1222 through 1226. We will be looking at different views. Let's let that one play through. As the heliospheric current sheet is currently crossing the Earth or recently just having crossed. We'll show you that in a moment. So here we've got the above view heliospheric current sheet. The run is from 1222 through the current time, near real-time data. A rift right here that we've passed through just now, and an incoming rift right there. Polarity will change due to the incoming solar plasma. We'll let that play through one more time. Never fear, this will be regular data on our channel. And lastly, let's take a look at this view. This will show you which field is at play. And it is the same run, once again, 1222 through the current time in nearly real time. Keep that like that so we can see the date stamps. Let it do that one full run. Giving you an idea of the magnetic influence on the magnetosphere. And here's the magnetosphere from a velocity perspective over a similar period of time. This is actually a little more current, and you can see some major velocity differences because of the changes in the plasma. Here's your velocity version of the same map. We'll let that play through once. Keep in mind, this is the density. Most recent hour. And lastly, here's the pressure. Here's your most recent hour. And here's the previous hours coming up right there. Changes reflected by changes in the heliospheric current sheet. We'll let that play through one more time, and then we'll go back to the data featured in the new segment. Oh, look, there's an anomaly right there, too. See that? Let's let that play through one more time. We're going to zoom in on that spot. Heavy density gradients. Check it out. Again, as the angle of this changes, current sheet up here versus current sheet down here, the change is in motion as the video is being made. And finally, just to let that sink in, here's the current data. You can see the charge disparity that's caused by the heliospheric current sheet. We're about to pass through it right on this rift. Looking for changes in the magnetogram and in the magnetometer readings. Thanks for tuning in. Please share with your friends. Share with your foes. Share with everybody who's willing to have an understanding of what's going on. Let's zoom in and see what it looks like from Earth. Yeah, there you go. Keep in mind, this is not any kind of catastrophe. This is just great data to tie together everything that we see. Thanks for watching.